All right, so there are many, many patterns that we can look at on the periodic table, right? One of the patterns we can see is like if we're up here and I asked you, Gabby, which one of these would be more reactive, chromium or potassium? Potassium. Yeah, you'd say potassium because potassium is further to the left. You know, the alkali metals are very reactive. You can't even get them wet, right? And we also studied that as you go down this group, they get more and more reactive. Like lithium fizzes in water, sodium explodes in water, potassium goes into a fiery explosion, right? So there are trends. Well, one of the trends that is very consistent on the periodic table is the size of an atom, all right? There's a periodic trend about the size of atoms, okay? And it goes like this. The very smallest atoms are in the upper right-hand corner. Helium is very, very small. And then the very largest atoms are the complete opposite in the lower left-hand corner. Francium is a very large atom. Now what that creates is a trend. If you look, here is something probably made by Linus Pauling. Here is a chart in the periodic table, and these are relative sizes of the atom. It's called atomic radii or the atomic radius because, you know, if you have a circle, the longer your radius, the bigger the circle is, right? So if we look here, as you go across a period, the atoms get smaller and smaller. Look, you go from left to right, bigger and smaller. Bigger and smaller. And that's not what you would expect if you were just glancing at a bunch of Bohr models like we're going to do now. If you glanced at a Bohr model, you might expect that let's do a Bohr model of lithium. Beep, boop, boop. And you would expect that a Bohr model of, say, nitrogen, which is further to the right on the same row, right? You might expect that a Bohr model of nitrogen will be bigger because it has more electrons in its outer shell, right? But here's the catch. It's smaller. It's smaller. This Bohr model of nitrogen would be much smaller than the Bohr model or the actual size of the atom of lithium. Now, why do you think nitrogen would be smaller than lithium if we were talking about the radius of the actual atom? Let me ask you a question. What is the reason that electrons don't fly away from an atom? What keeps electrons in the atomic space? What keeps them there? Protons. Electrons are negative, and aren't there positive protons in the nucleus? Right? So there's an electromagnetic attraction there. Now, obviously, as we go to the right across the periodic table, lithium's number 3. It's got 3 protons in the nucleus. But look at nitrogen. It's number 7. It's got 7 protons in the nucleus. So there's a stronger pull towards the nucleus. So as you go to the right across the period, you're adding protons. So you're making a stronger electromagnetic nucleus. So if we look at these atoms, lithium has 3 protons, 4 protons, 5, 6, 7, 8, 9, 10 protons. Look how small neon is. So you have this stronger magnetic nucleus, a more positive nucleus with a greater electromagnetic draw for electrons as you go across, okay? The last trend I want to show you is the fact that since every period the atoms get smaller as you go from left to right, another pattern emerges. And the other pattern is the fact that since we get smaller from left to right, and then we start over again, a little bit bigger, then we start over again, a little bit bigger, then we start over again, a little bit bigger. So it gets bigger as we go down, and it gets smaller as we go to the right. Now, since this pattern is consistent, it creates what's called the diagonal rule. Check this out. Look at these guys. What can you say about those? Yeah, they're the same size. So if you come here on a diagonal, since it gets bigger as it goes down and smaller as it goes to the right, if you go diagonally, then you end up with atoms that are very, very similar in size. Like, look over here. There's the diagonal row. Boom, boom, boom. All three of those guys. Same size. Basically the same size. That's the diagonal rule. So what I'm going to do is ask you to make a mark on your periodic table. You can make it in your official periodic table in your booklet. And I just like to do it like this. And then that's all I ever need to do. I just make a really small dot here, ding, and a really big dot right here. And if you look on my periodic table in the room, you'll see that same thing. That's all you need to do. If you just make a big dot here and a small dot here, then that'll explain everything to you. Does that make sense? Atoms get smaller as they go from left to right, and they get larger as you go from top to bottom. And that creates a diagonal rule as well. The end.